Let's look at frequency distributions. Here are the ages of the 56 signers of the Declaration of Independence. 40, 53, 46, blah, 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 49, 50. How can we represent this graphically? Well, we could use a frequency distribution table. First, put the values in order. In order, these values are 26, 26, 30, 30, 32, 33, blah, 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 blah. When we make a frequency distribution table, we could do this by hand or with a spreadsheet. Let's talk about frequency distributions. Here are the ages of the 56 signers of the Declaration of Independence. 40, 53, 46, 39, blah, 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 blah. How can we represent this graphically? Use a frequency distribution table and a histogram. First, put the values in order. In order, the values are 26, 26, 30, 30, 32, blah, 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 blah. So we make a frequency distribution table, or simply a frequency distribution, by hand or with a spreadsheet. Here's what we do. So there are 26 people who are 2 years old. There was nobody who was 27. There was nobody who was 28. Nobody who was 29. 2 people who were 30, etc. Here's what you end up with when you collect all of those data. And you can just represent this with a histogram on Excel. So these are the ages of the signers. Now, if this is a histogram, ideally these bars should touch. They don't. So sometimes Excel doesn't cooperate as much as we'd like. I've called this a histogram. Earlier we dealt with something similar that was a bar chart. Bar charts are for nominal or ordinal data, and histograms are for interval or ratio data. We're looking at ages, that's a ratio data, so this is a histogram. To be honest, I wish we didn't have 2 different terms. I wish we just called it one term, but it is what it is. Okay, rather than have something goofy like this, it's better to graph it into classes. Choose 5 to 20 classes, otherwise it's too difficult to see patterns. Okay, suppose we want 10 classes. Let's find the class width. That's the distance between lower limits for each class. Well, the class width is going to be the max minus the min divided by the number of classes. The min in this case is 26. That's the age of the youngest person. Maximum was 70. So the class width is going to be 70 minus 26 over 10. That's 44 over 10, in other words, 4.4. And we round up to the next integer to get 5. Okay, let's find the lower limit and the upper limit and the class midpoint for each class. The lower limits, well, that's going to be 26. That's the first lower limit. The lowest lower limit is the min, and we saw earlier that the min was 26. The next one's going to be 31. The class width, again, is the distance between lower limits for each class. So 26 plus 5 is 31. 31 plus 5 is 36. 36 plus 5 is 41, etc. So these are going to be our lower limits. The upper limits, okay, so if the lower limit is 26, next lower limit is 31, that means the upper limit is going to be 30. Because this first class is going to be 26 to 30. If this next class begins at 36, that means the second class has to go from 31 to 35. And then this goes from 36 to 40, etc. So these would be the lower limits and the upper limits. Okay, so we want to find the class midpoint as well. The class midpoint is the average of the upper and lower limits. So when you average these, you add them up and divide by 2. 26 plus 30 divided by 2 is 28. 31 plus 35 over 2 is 33, etc. Another easy way to do this is just to recognize that the class midpoints are also going to be 5 units apart. So shown here are the class limits. Find the class boundaries for each class. Here's what we mean by the class boundaries. Class boundary in this case would be 25.5 to 35.5. Here's what I mean by the class boundary. So I said that these are the lower and upper limits. Well, that's great, 26 to 30 and 31 to 35. What happens if you get 30.5? Where does 30.5 or 30.4, where does that fit in? Well, that's not in this class, and it's not in this class. So really we have to extend these classes a little bit to incorporate numbers like those. So we extended a half on each end. So this goes, it's not, the class boundary is not 26 to 30, those are the limits. And those are the class limits. The class boundaries would be 25.5 to 30.5. Extend each of these by a half. It would go from 30.5 to 35.5. Extend each of these by a half. It would be 35.5 to 40.5. Now, notice when we do that, all the numbers get covered. Now, to be honest, if we're dealing with ages, we don't need class boundaries because nobody says, yes, I'm 50.5. Nobody says that. I mean, ages are basically given as these integers, not as halves or 40.5. But if we're dealing with temperatures or something else that's measurable like that, well, we might need class boundaries. Okay, let's find the frequency distribution table. So here are ages 26 to 30, 31 to 35, 36 to 40. I'm going to be honest with you. I don't want to deal with 26 to 30 and 31 to 35. I don't like that. I'd like all the 30s to be in separate classes. So I set it up this way: 25 to 29, 30 to 34, and 35 to 39. I don't know. Maybe I'm just particular in that way. So I slightly adjusted it, to be honest. But don't do it my way. Do it the way the book does it. I'm just doing it this way because I just felt like it. Okay, so here's what we do. I would take 40. Okay, there's one guy in 40. There's one guy in 53. Okay, so we'll mark him there. There's one guy in 46. There's one guy in 39, so we'll put him in there. There's one guy in 38, so we'll put him in there as well. And you just do this for all of these ages, all 56 ages, and you end up with this. So this is our frequency distribution table, or simply our frequency distribution. Okay, let's graph the frequency histogram based on this table. Again, you go to the table, you graph these in histogram, and we end up with something that looks like this. Excel can do that for you. This is the frequency of the age of the signers. Graph the frequency polygon. So again, they're not going to be bars. It's not a histogram. Instead, you would just connect these with line segments. That's why it's called a frequency polygon. You end up with a polygon. Find the relative frequency distribution. Okay, we saw the frequencies. These numerators were the frequencies, 2, 8, 9, blah, 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 blah. To find the relative frequency, you divide by the total number of pieces of data, which in this case is 56. So the relative frequencies would be 2 over 56, 8 over 56, etc. And of course, they must all add up to 1. Got to get everybody. Got to get them all. Graph the relative frequency histogram. Here's the relative frequencies. When you make this into a histogram, you end up with something that looks like this. Notice on the side, instead of frequencies, we have relative frequencies. So for example, 25 to 29 is 2 out of 56, and that's why this is 2 out of 56. Find the cumulative frequency distribution. Here's what we mean by that. So 25 to 29, there are 2 people in that category. If we're talking about cumulative frequency, notice for 30 to 34, there are 10 people who are less than or equal to 34. So the cumulative frequency would be 10. For 35 to 39, there are 19 people who are less than or equal to 39. Sorry, that's not 3, that's a 39 there. And we end up with these. So all I did, you just add another 9 and you get 28. You add another 11 and you get 39, etc. And notice, you had better end up with 56 at the end. There are 56 signers. You better get them all. Graph the cumulative frequency polygon. This is called an ogive. So again, here are cumulative frequencies. When we graph this, we end up with a curve that looks like this. Based on these data, how many signers were 45 to 49 years old? Well, we can see from here that 40 to 44, we were at 28. Oh, but once we're in the 45 to 49 category, then the cumulative frequency is 39. So the answer would be 39 minus 28, or 9 signers. Ideally, you could see it from this graph, but I'm going to be honest with you, it's kind of tough to read things from the graph. I think it's easier to see from here.